Howdy team, I am going to record a little video of how to go about doing something similar to the flag project, but in this case it is an E project. So I'll show you what it is that we're trying to draw. We're going to start with just drawing a single E, and it's going to look something like this. So we have this little area here, I'm calling that a bridge, and we have some arches going up and an arch going down and another arch going down. And this is a line and just one little dot added here. So I'm going to first go into how we can write a program to show what this E looks like. This is it with 9. Here is an example of it with 3 and 4, 5, 6, 7, and 8. So we are going to start by building this E. Let's get started. So we talked about, I just mentioned that we have this sort of line here. We're going to call that the bridge. And so we need to identify which row this is happening in. We have a grid that's 9 by 9. And it doesn't matter what column we're in. We want a column in all of the X's in this row. But if this is the row that is in the center, then we want it to have X's. So let's make that happen here. I want to show you, first of all, what this code looks like. Right now, when I run it, it's just running, it's just printing out a dot for every so our size here is 11 since we are working on 9 before. I'm going to change that to 9 and I'll run it again. You can see that this is a 9 by 9 grid. Something that confuses me a little bit is that it is a 9 by 9 grid, which should look like a square, and it doesn't. So I'm just going to add a space here to help us see it as a square. Now it looks more square-like, and that will make it a little bit easier for us to work with. A few other things that I want to point out about this code. You can see this first loop goes from 0 to size. Our size variable is a 9. Then this goes, the columns also go from 0 to size, which is 9. So we have 9 rows, and each row has 9 columns. Then inside that, we're adding a value to a string. And we'll see later why we're adding it to a string instead of printing it. But we're adding to a string here. And so every time we loop through, we add another character to the string. And then every time we exit this inner loop, we're going to add a new line. So that's what starts the new set of our 9 characters. That's what makes it go to a new line. This, where we add the new line character at the end of our for loop that's based on the row. At the end, we just print that output. So now let's try to do, we want X's here in this center row. So let's define what center is. So in here, let's just create an int for center, because we're going to use center a lot. Everything seems to be based on this idea of center. So I'm going to make a center variable, center equals, and we did say, we're in, I guess the name of it as well, we want it to be in the middle of our box, I guess. So the middle of that box is going to be size, I guess it's in all caps, size over 2. That makes sense, right? So here we have int center is size over 2. This is just a value that's going to help us in some computation. So let's say we want to know if our character, if our row and column, where we are in the loop right now, we want to know if that is in this center row. So I'm going to create a Boolean. So Boolean center row, I guess we were calling it the bridge, right? So the Boolean bridge equals this. We want bridge to be true if the row is equal to the center. So if the row is equal to the center, we want to do one thing. And if the row is not equal to the center, we want to do a different thing. So now let's make that happen. If we want to do an if statement, we say if. So if bridge, we want to do one thing. I'm going to copy this in here. And then we have an else. We want to do another thing. I'm just going to move this in here. And because Java likes to be formatted properly, I am going to run format. Okay, so we said if it's in a bridge, if it's in the bridge, we want this to be an X character. So I am going, if we're in the bridge, it's going to print an X. If we are not in the bridge, it should print that dot. So I'm going to run it, and awesome. It's doing what we expect now. We have the bridge, we have X's for the bridge, which is great. I know though that we can have both even and odd, so I'm going to switch this from 9 to, let's try 10. What happens when our size is 10? Well, this is actually too low. Now we want this to be up by 1. So it should be either in the actual center or one above center, according to our document. Let's look at some of the even ones. So here, this is 8. You can see that our bridge is just one above. The center is really this line here, and we're going to go just above the line. So we need to modify our code a little bit to allow that. So we need to redefine this value of center such that it is the actual center if the value is odd, but we want it to be one less than center if the value is even. So let's take our size variable and we're going to subtract 1 here. So we want, like, I think that, let's just very simply, we have this value here. This is the center when X equals 10. So, or when size equals 10. That means this is index number 5. We actually want index number 4. So I'm just deleting 1 and we're going to see what happens. I'm going to run it. Oh. Do you know what it did? It was following the order of operations. So it was doing this division first. So 1 over 2 was being evaluated, which equals 0. So this was doing size minus 0, which is just size. So our center value wouldn't be doing anything. We want to put this in parentheses. And now let's run it. Okay, great. So now this is in index 4 or the 5th row, and this is totally working for evens. So we had it working for odds. Now it's working for evens. Let's see if it works for odds now with this change. And amazingly, it still does. So let's talk about why it does. So size minus 1 when size is 11. Size minus 1 is going to give us 10 over 2, which is 5. Now, if we didn't subtract 1, if this was just size over 2, it would be 11 over 2, which is 5.5, but we said that this is an int, so it's just going to be 5. So subtracting this value here gives us the right, like the correct answer, regardless of whether we are even or odd. So that's actually really convenient. So we're going to keep our int center at that value. And our bridge is, we just want to make sure that the row is center. If it is, then we're going to print the X, otherwise we're going to print the dot. Cool. Now let's bring in a different, so we've got the bridge, let's pick a different area. I think something interesting that I'm seeing is that in the center, see the center here? These seem to go together and these seem to go together, but we have this like center guy that isn't indicated anywhere else. So I'm going to draw that center guy. Why not? We'll do that next. So I'll call that Boolean top center dot. And top center dot is going to equal, well, we know we want it to be in that first row. So we can say if row equals 0, because we know that that's the case. It's only going to exist in that first 0th row. So we have row equals 0, and we want to know something about the column. And we said before that it's like the center. If we look again at the PowerPoint, it's in the center of that top row. So we can just use our center variable again. We know that we want this to be in 0, 1, 2 of 5. So that's the same as 0, 1, 2 of 5 in the columns, or yes, no, in the rows. We want it to be in the columns. So we're going to say if row equals 0, so that means it's the top row, and call equals center. So this should give us a top center dot right in the center. So now we want to print the X if it's in the bridge or if it's in top center dot. Cool. Let's run it and see. Yeah, now we have that X there. Let's go into a little bit smaller. So we had 9. That was the one from the PowerPoint that we were looking at. Let's run it at 9. And it does appear to be in the center, which is great. And we also want to try it for 8 because we also have that in an 8. What does it do? Okay, we have a dot there. If you notice in the evens, there isn't really a standalone dot. So we just want to make sure that where we're drawing this dot, there would be a dot there anyway. And this center dot that takes place at the center mark in an odd is going to take place one shorter than the center mark when it's even, which is right here, or right here, or right here. So you can see that in that space where we're printing the center dot, we're doing it because it would show up on the odd values, but on the even ones, you can see also that this would be an X anyway. So we're just going to leave it printed. Cool. So now we have the bridge and we have our top center dot. And now it is time to start with this arch here. So now we're going to add another Boolean. So Boolean top left arch equals. And what we know about the rows is that we want the top right arch to be in rows that are less than center. So we only want it on top of this center line. So our row 0, 1, 2, this is 3, which should always be less than 3. So we can say row is less than center. And then we want to say something about the column as well. So the column is going to be, oh, what will it be? We want to start here at center, and we want to move 1 over and 1 over there. So if we said we wanted to start at center, so let's say call equals equals. We said we wanted to start at center. So we're starting at center. let's just see what that does for now. Top center dot or top left arch. Okay. So now we're getting all of those, which is fine. We're making progress. We actually want this to be 1 over though, and we want this one to be 2 over. And that's the same relationship as the row number. So this one, we want it to be at center and 0 left of that. We want this one to be at center and 1 left. That's convenient because this is row 1. And we want this to be at center, but 2 left from that, which is convenient because this is row 2. So we're going to actually say equals center minus row. So we're taking the center value, which is this, and we are subtracting from it the row that we're on. So let's run it and see how that's going. That is looking very good, if we do say so ourselves. Let's try this for 9. We're getting odd here. Ooh, okay. So now we need to make a little tweak. So this actually should be over one more, I guess, cell. If you're talking about a table, we need to be 1 more over in the case that it's odd. Let me show you again. So when it is odd, you can see how you have 3 in a line here. So the arch that comes down reaches the 0th column. And then in an even, the arch that comes down does not reach the 0th column before the bridge happens. So this whole arch just needs to be shifted over by 1, but it only needs to be shifted over by 1 if the size is odd. So in the case that it's even, we don't need to make any modification. We have the case that it's even written already, but if it's odd, we need to move it over by 1. So here we have col equals center minus row. We also want to subtract another value. So we want minus something, but if I always said minus 1, then we're going to be off on our evens. It will work for our odds, you can see, but if we change this to our even, these should all be shifted over 1. So minus 1 doesn't work. Here, I think because we said it's the odds that need to move over, we can use that to our advantage. So we want to only move it over if it's odd. So we can use our even or odd check as a way to do that calculation. So I can say size mod 2 here. So this is going to equal 1 if size is odd, and it's going to equal 0 if size is even. That means that when it's even, this is going to be equivalent to center minus row minus 0. And when it's odd, it's going to be center minus row minus 1, which is exactly what we're looking for. So I'm going to run this again. What we're hoping to see here is these 3 lines shifted over 1. So let's run it. Yeah, we got that over. Fantastic. Now let's check it for 9 again. Cool. So this is working just the way we wanted it to. We have that top left arch doing just what we want. Okay. Let's get the top right arch. Oh, still in caps lock. Boolean top right arch equals. We still want our row to be greater than center, or less than center, excuse me. And so it is our call that we're going to do differently. So this one, we want to come down from, so this is the center marker. We want to go from 1 greater than center. That's where we want to start. So call equals center plus 1. This is where we want to start. It's just always going to do that, and I'm okay with it. We are going to fix it in a second. So I'm going to add top right arch to this if statement that's going to change our output. And exactly the way we expected, we have this straight line here. What we want is we want this to be over 1, and this to be over 2, and this to be over 3. So that's convenient for us again, because this is row 0, this is row 1, we want it to be over 1, this is row 2, we want it to be over 2. So it looks like this is going to be center plus 1, which is where our x's are right now. And we also want to add the row. So adding the row means this is going to move over just the 1, this is going to move over 2, etc. So if we run that, awesome. We have that working. Now, if we change this to an odd, is it still going to work the way we expect? And yes, it does. So it is only the one that is less than center, or it is this top left arch that is going to be modified based on how we do this calculation. Okay, now we need to get this bottom left arch. So let's start with that. And we know for this, the bottom left arch, it's only in rows that are greater than center. So let's start with that. Row is greater than center. And how will we calculate the column? Well, we know that regardless of the size, let's look at it again. Regardless of the size, it's always going to start in, we have the center here. It's always going to start in center minus 1 in that first column. So let's do row is, yeah, let's just start with this actually. And what I expect to happen is, oh, I should add call equals 0. Okay. Oh, I didn't add it to our if statement. So I'm going to do that right now. I ran it and it didn't do anything different. So I must not have made the changes. Great. So we can see that now everything is in this row. But I actually, so this one is placed correctly. But this one I want to be over by 1, and this one I want to be over by 2, and this one I want to be over by 3. And so I need to make accommodations for that. So it's not just call equals 0. It's actually going to be something else. So let's see. We have, this is row 0, 1, 2, this is 3, this is row 4, and I don't want it to move over at all, but in row 5, I want it to move over 1, and in row 6, I want it to move over 2. So it seems like this value of 4 is really useful to us. 4, in this case, if we abstract it, 4 is 1 greater than center. So let's say we have our row minus center. Let's see what that does. Awesome. Okay, so if we have row minus center, we're now taking the row that we're on and just subtracting the middle value from it. But we need these all to shift over 1 more to the left, which means we probably need to subtract 1 again, because we want it to move left 1. So let's run it again. Awesome. See how now we have that nice arch that we're looking for. Let's test it with 9. Great, that looks just like we want it to. Okay, The next piece we should do is, see this, these like bottom X's that go just along the straight line. It's always going to be from this value, which is, it's kind of convenient. This is actually center. So we know that it's going to be in the last row, starting in the center column, all the way to 1 minus the end. So let's do that. We're going to add another Boolean bottom line. Let's go with that, equals. So we know that the row is going to be the last one. The last row we know is going to be up here. So size minus 1. Row size minus 1. And then we also know that we want the column to be greater than, that is the wrong sign, column is greater than center. So let's try that. Oh, I did it again. Let's move this bottom line over. Now we'll try. Okay, so we have these. It looks like we're over too far to the left again, or too far to the right. We need to move one more over to the left. So let's say a column is greater than or equal to center. Awesome. Okay, but we don't want this last one to be included. If you look, this guy here is empty. So we will have to exclude him. So we know that we want column is greater than or equal to center. We also need column to be less than our last value, which is size minus 1. So this is going to give us everything greater than center, and this is going to ensure we don't go beyond size minus 1. So perfect. Now we have that open, and we only have one more little piece to cover, and that is this little dot here, which is always in the second to last row in the last column. So here and here, here, here. So we will do that. Boolean bottom dot equals. We know that the row is going to be the bottom row minus 1. So that is going to be size minus 2. Because we don't, size minus 1 is going to be the bottom row. We want the row just above the bottom row. So this is going to be size minus 2. And we also know something about the column. We want the column to equal, we want that to be the last column. So it should be size minus 1. I'm going to add, before I forget, bottom and dot to that. I'm going to run it, and now we have a working E. Let's try 8 here. Okay, that looks right. That looks good. Let's try an 18 just for fun. Yeah, it looks like our E. Let's try 11 because it's an odd value. We have 3. We have 3. This looks great. Okay. So we have now made our E's. If you are watching this video, probably for purposes of your learning, you should take a break. I'm going to take a little break, and I'm going to come back in a minute or two. Howdy team again, and welcome back from your break. I want to show you now what we will be building in the second part of our demo, I guess. So we're making a little flag out of these E's and calling it the wee flag. So you can see we have some stripes on the side here. We have some alternating of the E's. We have a border around the outside. So let's get started in making this happen. Okay, so the first thing I want to talk about is the idea that we're dealing with sort of two grid systems here. Let me go back to the PowerPoint. So this is what we're building. And I want you to think of, like, this is one row. This is a row on what I'm calling the macro scale, or the micro, excuse me, the micro scale. So on the smallest scale where we're trying to decide whether we put an X in the E, we're dealing with this as one row. But on a bigger scale, we could also think of this as one row in the grid. So in this row, we have an E and we have a blank space and we have an E and we have some filled in stripe. So this is the macro grid. We have the micro grid, which is this line individually, or this line individually, or this one. And that's what we've been working with so far. We've been calling the row, we've just been calling it row, but it's really the micro row, because there's also this idea of a macro row in a larger grid. So the grid we're dealing with here, if we ignore the borders for a moment, the grid that we are dealing with is 3 rows by 4 columns wide. So keep in mind the difference between the micro row, that's just like the actual one row and it's going to determine the X's and the E. But on the bigger scale, the micro, excuse me, the macro, the bigger row has to do with, is it a blank, is it an E, or is it a stripe? So micro is just the one little line. The macro is the bigger picture grid. So let's see first. We can ignore these borders for a minute. Let's just forget that the borders exist. And we're going to see if we can repeat these E's. Just, we're going to fill in everything with an E, 3 tall and 4 wide. So in order to do that, we need to come back to our code. Here in our for loop, we just call this value row and we call this value column, when in fact this row is actually just, if we start increasing the number of rows that we have, like here, we're increasing this, our row, once it hits size, isn't going to represent the same thing our row represents now. So we'll have to rename this. We're going to rename it in a minute. But first, we know that we want to be able to differentiate between our macro row and our micro row. So let's create variables for that here. So because we're defining row right here, determine macro and micro grid rows. So let's create a final int micro row, and we're going to create a final int macro row. And micro row is going to be the one that is determine the stuff on an individual line. Like, do we put an X here in the E character? Those sorts of things. So that we want a value that's going to be basically what is used in here. So these values can be from 0 to size -1, which means for micro row, we should probably set that equal to our actual row. So we're going to keep that row there. And we are going to mod it. You know what? It's bothering me that we have this row here. So I think that we don't have any value that just represents a row. It's more complicated than that. And I think naming anything with just individual row is going to be confusing. So let's rename this row. We're going to refactor it. We're going to refactor this value row. I'm not going to go the formal refactoring route because I want to keep those as errors for a little bit. So I want to call this overall row. It doesn't actually have anything to do with the grid. So I don't want to confuse it with any of our grid values, which we're going to call macro and micro. So I'm going to call this overall row, and I'm going to call this overall row. And then I'm creating variables for micro row. We said this was going to equal overall row, and we're going to mod it by the size. So this means that in our micro row, we're always going to get the offset of our E. So here, our overall row, I guess here, anyway, this value in our overall row, it is going to be 0, 1, 2, 3, 4, 5, 6. So it's going to be 6, which is our size. But we want to mod it by that. And when we mod it by the size, that means that we are going to have this value as 0, which will be perfect because that's what we're expecting, where we expect those X's to be when we talked about the top center dot and those sorts of things. So our micro row is overall row mod size, and our macro row is going to be the row in the larger grid. So is it the first line of E's? Is it the second line of E's? Is it the third line of E's? And we do that by doing integer division on the overall row. So we're going to do overall row divided by size, which means our row here, it's going to be, if our row is less than size, then our macro row is going to be 0. If it's greater than size, we're going to divide it by size and see where we end up. So if we are somewhere here, we know that we are greater than size, but we are less than 2 times size. So it's going to return 1. And that's perfect because this is the 0th value in the grid. I guess this is the 0th row in the grid. This is the first row in the grid. So our micro row and macro row are going to give us those values. Now, I left these as errors so that we would make sure that we got them all when we changed it. I want you to think for a second, these values that determine the components of the E, I'm going to make a comment there. Okay, so this is the components of the E. Are these based then on the micro row or the macro row? What do you think? It is the micro row. So it is these like little fine details in the micro grid, the smallest grid that dictate like the inner workings of the E. So I'm going to change all of these rows to be micro row. It's probably a faster way to do this, but I'm just copying and pasting. I know I'm going to get them all because they're all errors right now. Okay, so I haven't actually made any changes that should be visible right now. So if I ran this, I'm afraid to, because it would delete what we have written here. But if I ran this, everything should be exactly the same. Actually, I'm going to do it because I can get this output again. So you can see everything is exactly the same. I'm going to change this dot to just another space to make it easier to see. We don't really need to see the exact inner grid anymore. Okay, so we have the E as we expected. Everything is exactly the same. We just changed the name of overall row, and we've made sure that our micro row was what was used by the creation of the components of the E. The macro row is going to be useful later. We're just going to leave it right there. We're going to do the same thing for call. We're going to determine macro and micro grid columns. So here, I'm really just copying above, final int micro column equals something mod size, and final ints macro column equals something divided by size. Okay, and that something, we should rename this general column, which the idea of a generalized column just doesn't really exist anymore because we're dealing with this. We have two different column spaces or grid spaces that we're talking about here. So I'm going to change this to overall call. And I'm going to change that in all three of these places. Now this is also what will go here, because in our micro call, this is going to be the grid. It's this line in our microgrid in our E. And we are going to mod it by size to get the microgrid in the E, and we divide by size to get what place we're in, what column we're in the overall larger 4x3 or 3x4, whichever one it is, grid. So you can see all of these have errors in them now, and we can fix that by using our micro call variable, because it is the micro call that determines the inner workings of the E. So I'm going to change micro call, and here, and here, here. Now running it again, it should work exactly the same. Perfect. Okay. So everything is working the way we expect. However, we wanted to put like 3 E's or 4 E's in a row and 3 E's in a column. And so let's make that happen now. Here, we're going to say final int, let's call it calls wide equals, we wanted that to be 4, and a final int of rows tall, we wanted that to be 3, and something else that we're going to use later, but this is just the answer key. We wanted to have only 3 like spaces for E's before we start the stripes. So I'm going to say that we're going to create another variable here just for that. We'll use it later. Final int let's call it ease in row equals 3. Okay, so now if we run this again, we're only printing 1 E. Let's bring this down to 6 because it makes it easier to see. So we're printing it in size of 6. And if we want to print multiple rows now, because we have this idea that we have the micro row and the macro row, we've already figured out that the macro row is based on the modulus of the size. We can now multiply size by as many things as we want. So we want the overall row to be size times our rows tall. So this means that we are going to have enough rows so we're going to have size, which is 6 times 3. We're going to have 18 rows. What I expect to happen is we're going to have 3 E's stacked on top of one another. And that's exactly what we have. So now we can do the same thing for columns. I want 3 columns. So calls wide. So we're going to take size times columns wide. What this means is we're going to just add a bunch more columns. And because all of these are based on micro column, which mods the size, that means that we are going to have 4 E's wide and 3 E's tall. Perfect. They kind of don't look like E's anymore when they're all squished together like that. So we can start simplifying things. Let's try to get the blank spaces in the outer grid. So if we run this again, you can see we have these blanks. So I want to add a blank in the appropriate places. And to do that, we're going to need just a little bit of cleanup. Right now, we're determining whether we print a blank or we print an X based on all of this stuff that has to do with an E. And this is all just a little bit more detailed now, because we also want to do this space if we have a blank. So it's not just about these little independent E things. I think it's time for another variable. So I'm going to add a Boolean is E. And I'm going to set it equal to all of this. And now my if statement is going to just be is E. This should run exactly the same. We should still have the grid of 4 by 3 rows by 4 columns of E's. So now we want to start doing these like every other sort of situation. The every other meaning we want to have some of these grid or cells in the macro grid that are blank. So let's add a Boolean for, should this be a blank E cell of the macro grid? So we'll say Boolean blank equals, and we know we want it to be based on, like for the first row, let's just get it every other, we'll get some blanks in just the first row. So in the first row, we want the E's to show up in the even columns, and we want the blank to show up in the odd columns. So let's just say blank equals size mod 2. Not size, what am I thinking? I want macro call. So which column it is on the larger macro grid. I want to know if it's mod 2 equals 1. So if the macro call is odd, I want it to be blank. So here we only want to print the X's if it should not be a blank. So I'm going to say not blank and is E. So this means that if we have that it's a blank column, then that's the only time that we're going to output the X. Otherwise, we're just going to output spaces. Let's see what happens. What I expect to happen is we're going to have 3 E's and then a row of blanks and then 3 E's and then a column of blanks. I said row before, I meant column. So column of E's, column of blanks, column of E's, column of blanks. And that is exactly what we have. Great. So we have the every other concept for just that first row, but we're not alternating in the second row. And there are a lot of complicated ways to figure out how to do this in an every other sort of scenario. I spent a lot of time looking at it, and I came up with the observation that, let's go back to our PowerPoint in this bigger grid. So if this cell in the macro grid, so in the bigger grid, this E is at 0, 0. This blank is at 0, 1, so the 0th row and the first column. This is at 0, 2. This one is at 1, first row in the 0th column. This is the first row, first column, so 1, 1. So I'm naming these off because there's an interesting relationship between the two. If this E is at 0, 0, if we add those together, we're going to get an even number. This cell of the macro grid is at 0, 1. If we add those together, we have an odd number. Here, this is at 0, 2. If we add those together, we have an even number. Even numbers get E's. Odd numbers get blanks. So here, this is row 1, column 0. 1 plus 0 is odd, and therefore it's a blank. Here we have row 1, column 1. You add them together, they're even. Evens get E's. So as I said, there are lots of ways to do that math. You can do that Boolean logic however you want to. This was what I came up with. So instead of just macro call mod 2 equals 1, I instead want macro call plus macro row mod 2. And I'm going to run this. It's not going to do what we expect. So you see how it started filling in these things? When I first wrote this code, I was really puzzled about why it would be doing that. And then I noticed that we had an order of operations error here. So macro row mod 2 is going to be executed first because mod has precedence over the plus. But if I add these parentheses here, I end up with every other grid that I'm looking for. So major celebration here. We've come a long, long way. Okay, so now let's figure out the stripes. All of this stuff we're just adding thing after thing, and it's way easier than doing these individual things with the star. So we are most of the way there. Now we said, should this be a blank? Let's add a little bit more. Is this actually a striped blood? So when you have, run key again, when you have these filled in things. You call it like a flood or a fill. It's just totally filled in. So I'm calling it a flood, but you can call it whatever you want elsewhere. Okay, so is this actually a striped flood? So we're going to figure out now, right now, what our code is doing is it's printing this extra line of ease. And instead of this, we want it to be printing the stripes. So we're going to do that now. So I'm going to say, final int, it's not an int, final Boolean even stripe. And maybe it should be called is. Boolean variables are often called is even stripe. So these should all probably be is bridge, is top center dot, is top left arch. Maybe we can change that at the end. But for now, is even stripe. We're going to set that equal to something. And we're also going to have a final Boolean. These aren't changed, so they don't have to be final, but we didn't mark the other ones as final. These are all things that we can do later when we're refactoring. So we're just going to say Boolean is odd stripe. You can see that our even and odd stripes have, it's not going to let me execute until this works. The even and odd stripes just have different characters. So we are going to something else. Okay, so is even stripe is going to be, we know, let's see, we can pull up this one. We know that in the macro grid, so in the bigger scheme of things, the big grid, this, it's not going to be selected. There we go. This is, we know how many E's we want. So this is 1, 2, 3 E's. And then after the 3 E's, we start the stripes. So in the macro columns, the macro column has to be bigger than the number of E's. So is even stripe, this is just if it's a stripe at all, the macro column must be greater than, see how we created this variable earlier? We knew we would need it. So is greater than E's in row. And let's comment this out for now. We will look again. So if it's an even, then we use a pound sign, or I suppose now we might call it a hashtag. So let's add this at the beginning. If is even, what do we call it? Is even straight. Then we want output plus equals pound sign space. We want semicolon. This should be an else because we're building an if suite. We only want to do this one time. Format it so the Java is happier. What doesn't it like here? I don't know why it didn't just fix that. Okay, whatever. All right. So now I'm going to run it, and that did not work. So this should be if is even stripe. If it is the even stripe, which means if the macro column is greater than the E's in the row, then we end up printing this. I bet I know what our issue is. So E's in row is 3. And that is a count, not an index. So when we say macro call is going to have, since we know this is how many columns wide, our indices for this are going to be 0, 1, 2, 3. So we are never going to have a macro call that is greater than ease in row. I'm going to change this to greater than or equal to, which means that now we're allowed to use that index 3 that comes in it's 4 calls wide. So we have indexes 0, 1, 2, 3. I want to get that third one. So I added the equal sign so that when macro call equals calls in row, or equals ease in row, that this would be allowed. So now you can see this whole space. We're not doing anything about whether it's even or odd right now. We're just saying basically, is it a stripe? So now we should determine even or oddness. So because we have our stripe working, so we're going to say we're dealing with it. The thing that is even or odd is the row in the macro grid. So I'm going to say macro row mod 2, and we want this one is for the even stripe. So we're going to say equals 0 because that is what our yeah, that's what it is when it's even. So let's run it. I'm expecting this to stay, and I'm expecting an E right here because we're not doing anything for the odd stripes yet. Yeah, so now we have the stripe, we have the E, and we have this stripe. Our is odd stripe. I'm just going to copy and paste this. This is bad. Don't do that because we can make some mistakes, but we're going to look really closely. So is odd stripe. This is going to be the same. So we want the column to be greater than ease in row. And then macro row mod 2 equals 0. We actually want this to be equals 1 because now we're dealing with stripes, but odd stripes. So I'm going to copy this. This should be an else. And this should be is odd stripe, in which case we want to print percentage character. So now instead of this fill of hashtags or pound signs, we're going to have a fill of percentage signs there. So we have like a working wee flag right now for which we should say wee. Now the only thing that we have left, if we run the key, the only thing that we're not doing is we're not adding this border yet. So let's attack that and then we will be done with this business. Okay, so there's lots of ways to add borders. I know you can be creative. The way I was thinking I would do it is just inside here, like inside the loop, whenever I'm starting a new row, I was thinking I could just add left border. Like I'm just going to add a character here. So I am going to add, what am I doing? Output plus equals, and then a semicolon. I'm going to add that and a space. So this means I'm adding the left border. Let's run this and just make sure we should have a left border here and nowhere else. Great, that was really easy. We are going to copy this and do it here. I guess we don't even need a new thing. We can just add the border there. We're adding the space, but it's not really necessary. I'm adding these comments because it's not always so clear what's happening. Okay, so now we have both the left border and the right border. All we have left is the top and the bottom. So there are lots of ways that we can handle that. I think the easiest for me is going to be like at the beginning of this program to just add a border. So let's add, we're just doing the top border right now. So for int border call equals 0. We want border call to be less than. We want it to be about the same as this, or no, not rows tall. We want it the same as the number of columns wide this is. So I'm going to copy that. And then we want border call plus plus. So this is just a single independent loop that's not inside the other loops at all. And I think, so we have output here. I'm going to define output down there. And here I'm going to say string border equals empty. And then inside the loop for each border column, for each time that we go through this, I want to add a dash and a space. We're just doing this space to make it look square, remember? So I'm doing the dash and the space, adding that to the border for every iteration of the loop. So in every iteration of the loop, we add the dash and the space. Great. So we're going to say create top border. Now, this is going to be create middle part. So when we create the top border, now we have this. We have to figure out how to print it. Again, there are lots of ways to do that. I encourage you to look into others. I'm going to just have output start as border. So output equals border. Now, after the border, we do want a new line. So I'm going to add a new line to the end of it. So now instead of starting with the empty string for output, we're starting with the border. So now I'm going to run it. We have a top border, but we're off by 2. We are off by 2 because we added values. We added 2 to the width when we added these borders. So I'm just going to add 2 here. And that means we're going all the way across. Great. Now we need the bottom border, and that is just as easy as can be. So let's say add bottom border, and I'm going to say output plus equals border. And then we will print it. Easy as can be. So we have the border, we have our ease in the every other fashion, we have the stripes doing every other as well. We have all of these different things, and even with some fairly extensive commenting, we're only at like 75 lines. Lines of code, again, is never a marker of how really great it is, but it is, it shows how not terribly complicated this code is. So I'm going to add like one more comment, but basically this program is done. So okay. I'm not sure why it's upset with me. I'm just going to get rid of the finals here. They're not totally necessary. It wants me to make them all capitals. I don't want to do that. Okay, so that's the final program. I will make it larger so that it all, can I zoom? Make it so it all fits on the screen at the same time. So you can get a screenshot of it if there's anything that you're looking for. And with that, thanks for staying with me, team. I'm not totally sure how long this video is, but I'm glad that we were able to do it together. So yeah, thanks, team.